You can take your seats. We're going to start the next session, navigating trade wars and policy shifts within the global supply chain, global solar supply chain. Thank you all for sticking with us. I know there's been a lot of great discussions so far, but I'm excited to be here and honored to be able to moderate this panel with the experts that are on the stage here today. I've been in the solar industry for almost 15 years now. I started at a solar module manufacturer and have been in various stages of the project development cycle, now with Strata Clean Energy for the last 7 years. But I've always been in supply chain my entire career, the last 25 years. And there's no industry that I've experienced that is more dynamic and progress that I've seen in the last 15 years. So it gives me great pleasure to be able to introduce the panelists that are here, because I've known all of them for almost 10 years now, done business with each one of them. And they're great partners to work with and super knowledgeable. And you'll really find a lot of value in their insight. The first panelist I'd like to introduce is Nigel Cockroft. He is the U.S. General Manager at Jinko Solar. Nigel is based in San Francisco, where Jinko Solar US is responsible for PV module sales and the operations in US and Canada. He has been an integral contributor to the growth of Jinko Solar, from approximately the 10th position to becoming a leading module supplier to the US utility segment, delivering over 30 gigawatts to the United States market since joining the company 13 years ago. Nigel's background before joining Jinko Solar includes serving as head of North America System Integration Sales at GCL Solar, and as a senior director of sales at Hanwha and Hanwha Solar One. Before working in the solar industry, Nigel has served in the executive management roles in development, production, sales, and marketing for Silicon Valley-based fiber optics company, Gemfire Corporation, building upon a 7-year R&D management role at Los Alamos National Laboratory, and holds a PhD in physics from University of Canterbury in 1987, although he did not want me to refer to him as Dr. Cockroft. The next speaker I'd like to introduce is Andy Klump. Andy is the founder of Clean Energy Associates. Andy's solar experience began in 2006, when he served as Vice President of Business Development at Trina Solar, and he played a key role in the strategic expansion plans and fundraising initiatives. In 2008, Andy started Clean Energy Associates, also called CEA, or referred to as CEA, and over the next 14 years became a trusted partner to some of the world's leading solar project developers, owners, and financiers who provide various services across the value chain. These services include quality assurance, supply chain management, traceability, and technical support for clean energy projects. In 2022, Andy sold CEA to Intertek to combine with their comprehensive existing offerings such as product testing, certifications, and in-field inspections, which complements the expertise and creates a truly end-to-end service offering support to customers on their decarbonization and energy sustainability journeys. He stayed on board with CEA to assist with Intertek transition until last month, and interested and eager to see what he does next. And he holds a bachelor's degree in economics from Northwestern University and an MBA degree in general management at Harvard Business School. And Thomas Koerner, the corporate senior vice president of Canadian Solar, is with us here on the stage. Thomas started in the industry in 2002, where he worked for Schuco, leading their PV division, and eventually becoming their VP of Products and Business Development. In 2011, he joined Chint Solar, also known as Astronergy, as their general manager in North America and led their North American sales activities for 2 years. Thomas then joined Canadian Solar in 2012, initially as their general manager for North America, and has held roles such as VP of Global Sales, Corporate VP of Modules and System Solutions, and is now their president for Canadian Solar Americas and Corporate Senior Vice President. Thomas has been serving on the board for Solar Energy Industries Association and also NextWave. Thomas holds a Master of Engineering degree in Semiconductor and Microsystem Technologies from the University of Applied Sciences in Regensburg and an MBA from Steinbeis University. Thank you all for being here. To kick off, I'd like to just first set the kind of aspect of the industry. I know not everyone is well versed with the solar industry unless you're in my class, so you should know all this. But I want to just talk a little bit about where the solar industry is. The global solar industry is facing unprecedented challenges and opportunities due to shifting trade policies, geopolitical tensions, and evolving supply chain dynamics. The session brings together industry leaders, like the ones here, to explore China's dominant role in the solar manufacturing space and the impact of US policies and future of domestic solar production. So first, I'd like to just present to you, and this kind of gives an overview of what the solar supply chain entails. So there's basically two main technologies in the solar landscape. There's crystalline silicon, which is more than 90% of the capacity of the world's capacity is based on crystalline silicon. There's also thin film, which has lower efficiency, but is also another technology that is used in the market. Our focus will be on the crystalline silicon because it's the biggest, not only challenge, but also biggest opportunity. As you can see, the supply chain starts from quartzite, which is mined, and then it gets processed into metallurgical grade silicon, polysilicon, and then into ingots, which get sliced into wafers, produced to cells, and then assembled into modules. And so there are very significant shifts within the supply chain, and the value chain is made up of all of these processes and steps. The history of the policies relevant to PV module supply chain starts from trade cases that began in the early 2010s. In 2011, 2012, those petition filed by SolarWorld that resulted in anti-dumping and countervailing duties that were applied to products, PV products, coming from China. And since then, a lot of the US sources of modules and cells came from Southeast Asia, from Thailand, Malaysia, Singapore, Vietnam, and Cambodia. We've seen a wave of other import restrictions or duties and tariffs that have come to play. In 2018, the Section 201 tariffs were applied for imported modules and cells. And then there were cases that were brought about 3 years ago by Oxen Solar for anti-dumping and countervailing duty that talked about circumvention of that original 2012 AD/CVD that was placed against China. And now, and for the future, there's a lot more of these type of cases. Just in the last 2 or 3 years, we've seen the UFLPA, Uyghur Forced Labor Prevention Act, that has restricted and created detentions at the border where customs needs a plethora of paperwork to show where the sources come from due to forced labor concerns from certain regions in China called Xinjiang. And we are seeing in the last 60 days or so, all types of new tariffs that are being imposed. And this group and myself and many others in my shoes have to figure out how to plan our supply chains going forward. The other policy that has been very important and critical to the growth of solar has been the domestic manufacturing credits through the IRA. And as you can see, since the IRA's passage, over 85 gigawatts of manufacturing capacity has been added across the solar supply chain. And there have been more than 335 gigawatts of manufacturing capacity announced across the solar supply chain. So not just the module and supply chain, but also like the tracker materials, inverters, and other components that go into building a PV power plant. And module prices have been affected in many ways over the last several years. As you can see, the pricing, and this is data from NREL, from a report last summer that was released, you can see the rest of the world in terms of what the global spot pricing is compared to the US market. On average, it's 2 to 3 times the pricing that module companies have to charge in the US, either because of tariffs or other costs or other impositions where they're limited as to where their sources can come from. And the raw materials have gone up and down over this span of time. So the volatility is great, and it's only gotten even more volatile. So with that, I'd like to start off by I've already given a brief introduction. We're going to talk about the 3 different categories with this panel. The first is going to be understanding China's dominance in solar manufacturing, evaluating, and that's the first one, evaluating US policies and their impact on the global supply chain, and examining the future of US domestic manufacturing. So I'll join you guys. So Andy, my first question is to you. You moved to China back in 2010?
No, 2003.
2003. And you worked for Trina, and you got a taste of the culture there, right? And then you decided to start your own company. Tell us a little bit about why you decided to do that, and what were some of the challenges you faced getting into the solar market as a business owner?
Yes, so I'm originally from St. Louis, but moved to China in 2003, having the desire to help gain experience there for a little bit. I joined Trina Solar because I really had a vision that there would be Chinese companies that could help them go global, and the solar industry is exactly the opposite. That first chart you saw with all the red buckets, China was a fractional producer of all the components of the supply chain. So I remember it was about 5% of modules at the time, hardly anything on polysilicon, and somewhere in between for the rest of the components. To answer your question, when I joined Trina, the big gap I saw in the market is that there was no one who really understood what was happening on the ground. It took me about 2 years to learn Mandarin. I saw by walking along the lines in the factory with technical advisors and trying to help communicate and effectively be a bridge between both sides, I said, look, there's a much larger role that could be played. So I started Clean Energy Associates in 2008, really with that vision to say, look, the China supply chain is going to grow and expand. Other countries need to have access to knowing what's actually going on. So we really started off our business in 2 areas. First, on the supply chain management side, helping with procurement and helping folks navigate how to contract, and also make sure contracts go through with different Chinese companies. But then secondly, also doing the quality control in the factories. So we work with at many manufacturing sites like Jinko, Canadian, J, and others with large manufacturing presence in China. But we were the eyes and ears on the ground of different developers and IPPs. So we work with many leading downstream folks like Strata Clean Energy. And so we've been a trusted partner for many years. And that's kind of the origin story.
Right. Nigel, you joined.
Just before you ask me a question, I got to let everybody know here. Andy is very modest, but I think most of us that know him would say there isn't a single person in either the US or in China that's contributed more to helping the US to leverage the capabilities that existed in China. So, 20 years of hard work. He's been the bridge, essentially, between a whole industry in China and a whole industry in the US.
That's a great point.
And he's just moving to his next thing after so many years in this company that he founded. So hopefully the next thing will be just as big for him. Anyway.
So Nigel, Jinko being one of the top solar module manufacturers, how do you kind of talk to what has transpired to make not just Jinko, but other companies in China that have grown their scale and been able to modify or adapt to the environment, but also technology and the progress that they've made, where the scale of capacity in China is far more than any other place in the world?
Yeah, so just again, there's a few folks just entering the industry, so I'll just speak to that for a minute. I mean, first of all, a word, the solar coaster that many of us use. So the trade issues, there's always something. The industry goes up and down, but we all collectively kind of battle our way through it and keep it moving in the right direction. There's always policy changes. In terms of like the big picture of China, the reality is that China decided to do a lot more renewables. Of course, they have a lot of coal plants. They burn a lot of coal. They're also, and they've been phasing. They've been adding much more renewables, wind and solar and batteries than any other country in the world. So a lot of the growth of the manufacturing side of solar in China came about because there was tremendous demand for the product. And over the last 15 years or so, there's just been enormous demand. The market in China is much bigger than the market in the US, for example. And the rest of the world can leverage that capability. So it's really a demand-driven, and most of us would all agree, the way to make a healthy industry is to have a healthy demand. The manufacturing can follow from that. And that's why China has dominated, is just the tremendous demand. And then, of course, a lot of companies, including Jinko, also took that technology into other markets. So we're at a little bit of a transition point, which we'll talk about today, where a lot more of it is coming to the US. And I'll just say one thing about that now. What has happened is that everything has become, all manufacturing has become extremely automated, robotic, and uses a lot of AI actually for lots of things. You can do things with AI and robotics that you could never do before. So the amount of labor involved in making solar panels has been reduced by a factor of 10 or so over these last few years, and that actually makes it more feasible to do it anywhere in the world that you want to do it. So that's one of the things that's happening now.
Thomas, can you tell me a little bit about Sean and how he started Canadian Solar?
So first of all, great to be here. Thank you for inviting us and sharing the vast different experiences we all have and bringing that all to one point. Sean founded Canadian Solar in 2001 in Canada after working for solar and semiconductor companies, basically in his garage. And the first product we ever developed and sold was a little car charger. So when VW and Audi was bringing over cars manufactured in Europe into North America, the batteries were just drained. So we developed a little product which goes to the inside of the car and charging and keeping the batteries up to date. That was the founding product. And today we are one of the largest, not only solar panel manufacturers, but at the same time, we have changed significantly into an energy provider. We're one of the largest battery manufacturers. We're one of the largest project developers, one of the largest system integrators, including our own inverters, and other key components, because we understood that at one point, it's more than just a product manufactured cheaply in China, which we do, of course, as well. But it's more to provide a true energy solution and an energy system down the road. And how cheap you can really generate clean, sustainable, low-cost electricity. And we heard about that in the presentation before. Energy cost drives demand, and the demand in the US has spiked significantly and probably will grow further. We have experienced the same situation in the US market with imported products. Over the past years, we have seen so many import cases and import duties where the product could have been imported and sold significantly cheaper. We as a manufacturer, of course, have to adjust and adopt. We hurt significantly, but at the end of the day, all what it does is increasing the product pricing in the market, and the end consumer has to pay for it indirectly through higher electricity cost or directly through higher product cost, like Strata Solar and other companies who are buying these components. So at the end of the day, we have to be sure to understand what does it truly do, and what it has done over the past years significantly disconnected the US market cost and price-wise from every other market globally.
So Nigel, your factory in Jacksonville, Florida opened up in what, 2019, is that right?
Yeah, 2018.
2018. What has changed in those, in the last 6 years where you feel like the U.S. manufacturing can compete with China from that from your
Yeah,
perspective?
so maybe we'll talk a little bit about some of the challenges and some of the opportunities. But actually, just one very important point that was in the slides, but it may not be obvious. To those of you not so familiar, solar panels have not come from China to the US market for something like 10 years. The early trade cases essentially put a prohibitive tariff on a solar panel that came directly from China, and then there was 3 or 4 other cases, as Lenny put up there. So most of us built large factories outside of China. We went to Malaysia first. We've got factories in several countries around the world. So we had supplied product to the US from Malaysia for a number of years, and more recently from Vietnam. And we have other elements of our supply chain in several other Southeast Asian countries. And we also are building a large factory in Saudi Arabia at the moment. And we built this assembly plant in Jacksonville, Florida, started 2018, and we recently upgraded that as well. So I think that what I said before is true. The amount of labor required with new equipment now and AI and so on has reduced considerably. So our factory space that we had set up in 2018, 2019 as 400 megawatts of output is now a 2 gigawatt output in the same space. And of course, the international prices of the equipment that you need have also become more cost effective, although when we import that to the US, we have to pay a tariff on the equipment, but it's still come down in price over time. So I think the driving force, of course, for additional expansion in the US is twofold. One is just ongoing country-specific tariff cases brought about by a very, very small handful of players in the US. The US trade policy favors the underdog very dramatically and surprisingly. If you look at the details, you would not actually believe it. But you can be a company that makes pretty much nothing, and that's been the case. They bring a trade case and it can cripple the whole industry and cause the whole industry to need to move to other countries and do a lot of work on the supply chain changes, which happened very, very quickly, by the way. So anyway, in terms of the most recent developments, of course, the IRA provided manufacturing production credits. 2 things, actually. It created a demand for the projects for our customers with a long horizon. So you build factories if you see there's a long horizon for selling that product. So the demand side of the IRA was very important for that. And secondly, because factories in the US are more expensive to operate, so you can't expect to export these solar panels from here to other parts of the world who get a much cheaper solar panel from China mostly. And then, of course, there's 45X production credits for producing and selling the product in the US as well. That's provided a significant incentive. However, in my opinion, and in Jinko's opinion, you really need to do that in depth across the whole supply chain. The IRA incentivizes a little bit disproportionately the assembly side of a solar panel, and the incentive for a cell is less, and the investment is much more substantial, and the payoff time of a cell factory is more substantial. So, and cell factories take significantly longer to put together, and it's difficult to find the right resources in terms of electricity, water, and everything else you need to actually locate a cell factory. But all of that is happening as we speak. Canadian has moved forward on that. Jinko is also, things on the horizon we haven't announced yet. So this is the interesting moment. And again, a lot to do with the equipment and the efficiencies, and of course, quite a lot to do with the IRA incentives as well.
Andy, you've been to a lot more factories than anyone I know. Can you just talk a little bit about what you see as their the benchmark that is much different to meet here in the U.S. and other countries, and why are they so much more advantageous than new factories that are trying to be built?
Yes, I want to build off the comments that Nigel mentioned, and also answer your question, Lenny.
Yeah.
And one of the things I learned in China, working for a manufacturer, and once again in 2006, the global solar market was 1.6 gigawatts. Trina Solar had a very small 75 gigawatt module line, as well as 75 megawatts of both capacity, both for ingots and wafers. And they were just in the process of installing cells. So I'll tell you a little story. This will kind of answer the question. Right around early 2008, my former boss and CEO, Mr. Jifan Gao, said, Andy, we're going to set up a Changzhou PV park. The government's allowed us a plot of land very close by. Go off and make this happen. I was like, what are you talking about? He said, we need to have a big party in 30 days to celebrate the opening of the Changzhou PV park. And I pointed out my window and I said, I see nothing but dirt and a scrap lot. There's nothing there. And he said, there's going to be something there in 30 days. I'm calling construction crews. They're going to start to level trees, and we're going to build this out. But I need to have this big groundbreaking ceremony in 30 days. So I said, okay, so how do you want us to do that? He said, start calling suppliers. Tell them to sign, come here. We're going to sign non-binding LOIs for the first 15. They're going to get great precedented, great incentive. I said, okay. So we started calling companies, started with, glass, aluminum frames, went down all the subcomponents that Trina manufactured and said, we're going to start this off. And effectively what Trina did was creating this cluster of all its subcomponent suppliers. And it wasn't just Trina doing this. It was Jinko, it was Canadian Solar. Every major manufacturer realized that, hey, we need to have a systemic advantage. We have to have our suppliers co-located at these facilities. And so within 30 days, we had the kickoff, and everyone there, we cut the ribbon, broke ground, and we were off to the races. And so what the U.S. doesn't quite understand, and we've seen tremendous policy support with the IRA, but you can't just incentivize modules, cells, ingots, and wafers. You have to look at the overall ecosystem. What are all the subcomponent companies doing? Because the reality is, as Nigel said, they still have to import all the automation equipment. They have to import a lot of the other subcomponents. And so starting off in 2018, as Jinko did, it was still very early, very bold, but when they get hit with the subcomponent tariffs, then they're at a really disadvantage. We're now at the point where we have 50 megawatts, or I'm sorry, 50 gigawatts of module capacity, which is great, but guess what? The cell technology is what we're lacking. Jinko, Canadian, others are in the process of building this out, but you have to think about the overall ecosystem. Cell technology is where the absolute kind of brains of the solar module are, and you have to invest in R&D. So you have to invest, guess what, with those who have 80 or 100 gigawatts of capacity. You want access to that R&D budget, and right now that sits in China with Chinese manufacturers. So my comment whenever I talk to anyone, and once again, solar is a bipartisan issue. It doesn't matter if you're Democrats or Republicans. We all care about energy security. We all care about domestic manufacturing. But we want to also be manufacturing with the latest and greatest technology. And that's why we're partnering with those who have the technology is extremely important. And so that's where, to answer your question, I think we really, in the U.S., haven't looked holistically at that solution. But this is important in the next phase of development that we continue to augment and bring more technology to the U.S. and allow that manufacturing base to continue to grow and evolve.
Let's talk about trade policies now a little bit more. The UFLPA, 3 years ago, the WRO came out, shipments were stopped at the ports. I know Jinko and Canadian suffered a lot of just churn in providing documents to Customs and Border Protection. What has that process, how has that evolved since then? And how have you ensured that your supply chain can be not only compliant, but ethically, sourced? And can you talk through that? Either one of you.
Maybe I'll go.
So at this point, it feels like more over the past years, I became more a trade lawyer than anything else. We had to dig into so many details, and more importantly, we had to educate, especially the US government and CBP, so significant in every detail, what manufacturing in general, means, how it looks like, and how it's being done, including bringing CBP people and teams into our US facility as well as to our Thailand facility. Because we're talking here about a requirement, a request which was set up, and none of the teams had a clue what to look for. So the education level and how we basically set up the structure of documentation and details and background was a massive undertaking. And I think we have now overcome the concern about where certain materials and components are coming from. And we have now stepped forward that everything basically is cleared and clean, and people feel confident where at the end the sourcing up to the quartz lab is coming from. Other countries are not yet there. And we have other manufacturers in areas coming into this, which are facing right now the same scrutiny and the same issues. They still have to adapt and to learn first. So it was not insignificant, but it was one of the many topics you mentioned over the past years we had to work on. And I got it that solar is a high, I call it a visibility product and a component and part, but many other parts in the industry as well. Now we're seeing similar discussions going on, for example, on the battery side. One of the reasons we are right now setting up a 5 gigawatt hour battery cell and battery assembly factory in the US as well is to prevent that something may happen also on the battery side. The PV module itself was an important part. Nowadays in the PV system, not that significant, and more other components and parts becoming more important. But as Nigel already mentioned, and Andy as well, the assembly is one part, but we have so many other key components and parts in the entire ecosystem, from a junction box, from glass. Find a glass manufacturer here in the US who provide the respective quality and quantity and cost competitive in solar glass. Doesn't exist. So we have still a long way to go for every component and part to create this ecosystem here that we can be truly independent if we truly want to do that, because it has its price.
Yeah, actually, I'll go backwards from what you just said. The infrastructure is it's a kind of a theoretically a build it and they will come kind of a thing. I mean, there's a tremendous opportunity for glass to be made in the US and sold into these US factories, but of course the glass makers have to be confident the IRA will hold for their customers, namely people like us who would be buying that, right? So anyway, we'll see what happens with all of that. Uncertainty is the enemy. If there's rumors and discussions of changes to incentives, it slows down investment. Back to the UFLPA, that's very important. So there's actual tariffs, trade policy around tariffs is one discussion, but there's other things that have affected solar in a big way. The UFLPA is a big law, actually, preventing the use or the importing of any material containing anything from the province of Xinjiang, unless you can prove, which they generally won't let you prove, that anything from Xinjiang is okay. So in other words, it applies to every single product brought to the US. But when they passed the law at the last minute, they added polysilicon as one of the three critical priority industries. There was tomatoes and cotton for textiles and polysilicon for essentially for the solar industry. It was not in the original draft, but it ended up in the final bill. So what happens is Congress, passes a bill, the president signs it, it goes to agencies, and then agencies have to decide, they interpret how to actually enforce that. And the reality is, this was handed mostly to CBP, Customs, and they did not have really any clue about solar panels and how things were made. So they just went out and stopped the two biggest importers, one of which was Jinko, stopped everything, disrupted the industry for quite a while. And we worked very, very closely with them, explaining, what the solar panel was and how it was made and all that sort of stuff. And it took a while, but every single container that we had detained was released. And of course, we learned an enormous amount. We have, 5 lawyers on team now in the US. We've got trade compliance groups everywhere in our US company as well as our factories. And we had not even used an ounce of Chinese polysilicon in any of our product. We were using European and US polysilicon and making wafers in our Vietnam factories outside of China. So we were the least dependent on Chinese POM, but it didn't matter. The government and the customs stopped it anyway, and then it took a year more or less to get through till they believed that that was really the case, which they ended up doing, and we're in good shape now. The reason I say all this is because it's kind of not for the weak of heart, if you like. You have to be really committed to the US market. You really have to stay through it. I don't know how much Canadian Solar spent on this. I think an enormous amount. We spent literally a few $100 million getting through that, and we didn't have a single solar panel that was actually in the end excluded. In other words, we'd done nothing wrong, but it doesn't matter. And the other unusual thing about the US customs side is they either stop you or they don't touch you at all. So there are many suppliers coming into the US that have never been stopped, and they certainly aren't necessarily all doing the right things. But maybe they'll keep doing it until they get caught and don't have to anymore. So you end up with a disparity between the companies doing the very good and expensive supply chains that are, fully compliant, and you have a higher cost against some other folks that aren't doing that, but they'll do it till they can get away with it. So it's sort of an unusual time at the moment.
Andy, you, I think, represented a lot of buyers like us to be in the factory and validate that, where the materials are sourced from. Can you talk a little bit about some factories that you visited that made you question, whether or not they're coming from credible sources?
Yes. No, look, the reality is there are absolutely a lot of non-tier one players who have been engaged in, I think, unethical practices. I myself was in Indonesia about 12 months ago walking through factories. I had one particular cell factory I was interested to see. They took extra long in having me set up the visit, and I just thought it was very suspect. I had to wait outside for another 30 minutes, and then I was finally ushered in, and all the equipment was 15 years old. Maybe even 20. I had seen some of that back in 2006 or 7 when I was at Trina. Very shocked that it was even operational, but they had people running around working, and no doubt in my mind that they were clearly getting cells from China, repackaging them, relabeling them as made in Indonesia, and then sending along to elsewhere in the supply chain. That is a rare exception, though. There are a lot of legitimate manufacturing facilities in different parts of Southeast Asia and elsewhere in the world. But our teams are definitely very trained to look for things. I will also say we have a very strong code of ethics at CEA, and a strong set of core values. Do the right thing is one of the core values that we celebrate. And our teams definitely have had cases of receiving bribes, and those get escalated right up to me when they happened. And immediately I would be talking with the GM of the factory and the CEO of the manufacturer. So those happened at some of the facilities in Southeast Asia. But I want to bring your topic a little bit more broadly and just say what are some of the challenges of new manufacturing. And the reality is it's not just manufacturing at some of these less well-developed countries. Even manufacturing in the U.S. at a new facility can also have a lot of challenges. And one of the biggest engagements we had was a Korean manufacturer using German technology, in Dalton, Georgia. Many of you know who those are, who this manufacturer might be. We had a 2-person team planning for a 2-month engagement, ended up being 12 months, and we had to quadruple the staff, ended up going up all the way up to 8 or 10 folks for the course of a whole year. So ramping up a new manufacturing facility is not easy. There are a lot of defects and a lot of challenges that can happen even in the United States. So, once again, that's also a key message that you have to trust but verify. And that's where we end up doing a lot of the work. We were talking about upstream validation of the raw components. Those are all things that everyone who's buying modules or an off-taker, they need to be understanding where these components are coming from.
So I'd like to talk a little bit about the future of solar manufacturing and your supply chains. So Thomas, can you talk a little bit about what your plans are to help with navigating all of the anti-dumping, countervailing duties, Section 201, more tariffs on steel and aluminum, and how is Canadian Solar dealing with that, and what are your plans? And then also talk about the technology in Asia for Thailand, your Thailand factory, and what your U.S. factory, plans to do and how they plan to replicate the operation and the capacity that you have.
Got it. Very broad question. I'm trying to chop it down to small segments and elements. So today we have a 5 gigawatt module facility up and running in Texas. And as Andy said, to get a facility up and running is highly difficult from a workforce perspective, machine technology optimization perspective. It is challenging. And to give you also some perspective, a facility here in US, including the import duty on machines and equipment, the higher labor costs and everything connected to that is roughly between 4 and 5 times more expensive than currently in Southeast Asia. So we have seen your graph before, where globally right now, PV module assembled sales price off the gate is around 8 to 9 cents. In the US, we're talking about 22 to 30 cents. So 3 times more at least. That's the price we have to pay for, and we need to pay for, if we want to have certain products assembled, produced locally. At the end of the day, it's about, does the market request certain things, and does the law require you to do certain things? So we always say we do as much as we need to do, but as little as possible, as long as we can stay costly competitive. Because the project, at the end of the day, utilities, IPPs are putting into the ground have to be cost competitive on the electricity they're selling. If they're not, the US market would shrink, versus the demand on electricity side we are seeing is significantly increasing. So it's always a balance. How far do you go? How much do you want to do? Therefore, we are also setting up our 5 gigawatt PV cell facility because it provides a certain local content percentage the IRA is requiring, plus additional components we're producing in the US as well to get over the respective limits. But doing all that, it takes time and it takes an incentive to bridge the cost delta. We have seen since 2012 different trade cases, whatnot. And what it has not done was it has not created factories. It has not created jobs. Right. Besides certain manufacturers, like Jinko was one of the first ones with a test facility and some others. Yes, there are some smaller ones trying it out, but nothing substantial. Manufacturing and bringing supply chain back happens when it's incentivized. We have seen that in Brazil. We have seen that in Taiwan. We have seen that in Canada. We have seen that in Europe. Whenever there's an incentive, a carrot, then it works. A stick over the last years has never worked. It only made it more complicated, more expensive, and more fluctuating depending on how long a certain law is in place, how long, when it's being challenged, etc., etc. Long-term, consistent policies and incentives was the key through the IRA to bring massive manufacturing back. So coming back to your complicated question, so we do as much as we need to do. We're currently investing more than $2 billion in the US market. Shows you A, the commitment, and B, how the IRA actually is working out. Mm-hmm. Make sense?
Yeah, absolutely. Nigel, how do you think?
Yeah. It's just, I got to echo some of that. I mean, the stick of tariffs has not produced anything in the US, right? It's supposed to increase the price of the product that the imported product, so that a domestic manufacturer can compete. It simply hasn't worked. 2 out of the 3 companies that have created the most trouble since 2012 are not in business anymore, and the others not doing that well either. So, and I'm not talking about First Solar, I'm talking about some of the earlier ones. Anyway, the point being that, the carrot works, and it's not just on the manufacturing incentive side, which is very, very helpful. It's on the demand side. In other words, companies like us need to look and see that longer-term demand. We know the electricity demand is there now, by the way, but a lot of this, this rapid growth in electricity demands occurred in the last year or two. So, and yet our investment's going to start at, a little bit earlier than that for this latest growth. So, anyway, but was there more to the question? I'm sorry.
No, it was just about your future plans for manufacturing and, navigating the
So just in general, I mean, you hear the number 5 gigawatts talked about sometimes. That's kind of, this is an important issue. It's very difficult for a company that would make just 1 or 2 gigawatts, especially if they didn't have the global presence as well, to ever be able to keep up with the technology. But bottom line is that there's an economy of scale that lends itself to something in the range of 5 gigawatts cells or modules. And so Jinko is doing more, and numbers like that are the numbers that make sense.
Yeah,
we have an announcement.
And I just want to build on this. What's also important is to understand what is the latest technology that is being deployed. And unfortunately, a lot of the trade uncertainty is what leads folks to say, okay, well, maybe we don't bring the latest technology, we bring a generational technology. Ahmad mentioned this in his session this morning about using PERC technology. No one's deploying PERC anywhere else. So this is an older technology, but once again, because of some of the IP concerns and other issues, folks are hesitant to say we want to make that big investment. But let's not talk about just the 5 gigawatts here, the 5 gigawatts there. We need to think about who's going to have 10, 20 gigawatts in the future and really be bringing the latest technology, because solar technology on the cell side, it goes through a 3-year cycle, maybe a 4-year cycle, but you always have to keep planning for the future growth. And that's one of the things that's extremely important, is that consistency over time in deploying new technologies.
Great. Yeah, I know that was my next question, so I appreciate you bringing that up.
Yeah, there's a second. Well, first of all, for the record, Jinko will not be. I mean, Jinko will be bringing latest and greatest to the US. We won't be relying on PERC. But anyway, that's a small point for me. The point is that there is an important thing here, though. Like, for example, our factory, we operated here. Because you're paying tariffs on the equipment, it's more difficult, and you have to get a lot of permits and import all sorts of things, licenses here and there. It is actually more difficult to upgrade the technology here in the US. So our experience with our factory in Jacksonville was that we had to keep that same equipment there, and it became obsolete. We would have done like maybe 3 generations of equipment in Southeast Asia where you can swap it out with new stuff over that 5 or 6 year period. But yeah, it took us 5 years to really feel like it was time to rip it all out and bring in new stuff. Whereas that keeping up to date is historically a lot easier in Southeast Asia or China.
Andy, I'm curious, what's next for you?
I'm not. I've announced to my close friends I'm taking a sabbatical. So I've been a father of 4 daughters for quite some time, but on the road quite a bit. So I've not made any announcements of my next plans, but except we'll be moving the family to Boston after 22 years in Asia. So we're moving this summer, and I look forward to being a little more hands-on father. But there have been no shortage of opportunities, and if I have to echo the comment that Dan Sugar made over lunch, I could be more bullish on the market. Yes, there are some tariff issues and some regulatory uncertainty, but the growth is just, I mean, we're just at the cusp of massive growth. I mean, since I joined the sector, we've seen over 350x growth in the last 19 years. But there's a lot of growth to come, and so we need a lot of bright entrepreneurs and investors, developers. The whole ecosystem needs to be engaged on really growing this sector. So I'm excited to be part of that in the future.
Yeah, no, that's great. Well, thank you all. I'd like to give time for the audience to ask a few questions. Catherine? Yeah, right there.
Yeah, Thomas, to get back to your number, it's 4 or 5 times more expensive to build a factory here. I've been in the big factories in Asia together with Lenny, and they are on a scale that is already 2-3 times bigger than anything here, even in Vietnam or in Thailand. How the heck do we want to compete with Asian factories if we don't have the intellectual property, much higher permitting cost, everything else? The scale is not there. Why are you guys positive that we can close the gap between US manufacturing and Asian manufacturing? Or do we have to anticipate that the current gap of a panel being 2-3 times, maybe 4 times more expensive here than it is in the rest of the world? Is this something we should get used to, or shall we accept it? Or do you think that there is ever, with all these things working against you, a way out of this trap?
So you talk about US manufacturing cost versus Southeast Asia.
Yes.
My opinion in that case is no.
Technology.
I think on an apples-to-apples comparison, the gap cannot be closed. We have very substantial different cost impacts. Alone, I'll give you one example. If you build a facility in China or in Southeast Asia, they're very similar. To ramp up a new 10 gigawatt cell facility takes you 1 year. Maybe 9 months, maybe 10 months. Take a guess how long it takes you here, including permitting time, engineering reviews, site reviews, etc. It takes you 3 years to get to the same level. And time is money, as we have said a couple of times. This time needs to be paid. Your construction company needs to be paid. The engineers needs to be paid, etc., etc. It's a long tail of additional cost and elements which you simply can't avoid anymore. We need to differentiate between strategic manufacturing and just, I call it high-tech commodities, because if you're comparing it to a flat-screen TV, none of the flat-screen TVs are being produced in the US anymore. You can go today to Costco getting for $500 a high-efficiency 4K flat-screen TV, and nobody cares about. That's what people want. If we truly decide that a PV panel is a national security topic, energy safety topic, then we need to be willed to pay this higher cost level. If we don't, then let's produce it there where it's more cost efficient. It's a trade-off. And I think policies and market demand and off-taker concerns will regulate that automatically to a certain extent. We do what the market wants us to do, but back to the question, I don't think that the cost gap will be ever closed. We're coming closer, but it will stay there.
Yeah, if you separate the cost and the technology gap, I think the technology gap is going to be a lot closer than it used to be. But there's a very important point, which is that it requires vertical integration and it requires access to everything. For example, the quality of the wafer depends a lot. So if you get to the point where you can't import a high quality wafer from a Southeast Asian like Jinko, Vietnam, for example, is where we make all of our wafers for the US. If we can't import those and we needed to try to do it in the US, then that's another step back, right? So, and we would always need access to have the very best product. We need access to the very best wafers and the best polysilicon from around the world. We don't use China, but so on and so forth. So everything has to kind of keep up. And I think there'll always be some sort of lagging bits and pieces, but I think the gap on technology will be less than it used to be.
I think what was telling was when Hanwha, failed their REC silicon for their own wafer production here in the U.S., and they decided to retreat from that strategy.
Interesting topic.
It's not as easy as it looks.
I think the REC facility is an old polycrystalline facility, which was state of the art at one point. Mm-hmm. We have now all moved over to monocrystalline silicon and the monocrystalline silicon grade and purity. So REC has tried to bring over this old facility and upgrade it so we can produce the higher purities, and it simply didn't go as expected.
Right.
So technology moves very fast, and we're talking about technology validities of 2, 3, 4 years, where these investments, especially in the US, they need 10 or 15 years to write off and to get the money and the investment back. There's a mismatch of the technology speed in the market versus what US manufacturing in certain areas can do.
Any other question? Yes.
I just want to give both of you personally and also your companies at Jinko and Canadian Solar and huge shout out. Oh, thanks a lot.
Yeah, I want to give both you personally, Nigel and Thomas, and your companies a huge shout out for investing in the U.S., building out, dealing with, a whole flurry of trade policies, including some folks that subverted U.S. trade policy to their own commercial benefits, and powering through all that, delivering really high quality products to support the industry, building out clean energy jobs, and just powering through a very, very challenging period. So it's just great to see the factories that you've built, and we know you're both continuing to build out. So, and we have just the best wishes for your success. So thank you for everything you've done, because the solar industry would be way further behind where we are in the U.S., but for your efforts. So just thank you very much for that.
Thank you back, because I think you have right now the most factories in the U.S. right now producing key elements of your tracker, next tracker at this point. So
Thanks a lot.
Yeah, thanks, Dan.
And this is actually, it's good to also segue a little bit to follow up on Marcus's question. His question was specifically on modules and the crystalline supply chain. But I think one of the things we have to look holistically is that a total installed per watt cost. And there still are a lot of non-component costs that can still be ground down. It's about how do we find ways to reduce permitting, reduce all the other soft costs around the system. And that's where we have to keep growing and evolving. But yes, I wish I could be more optimistic, but I kind of do agree with Thomas. I think there will be a gap. But still, if you look at the levelized cost of energy and where solar is going, we saw the slides earlier today. It's absolutely moving in the right direction. It is cost effective, and cost will continue to go down, even though the U.S. cost will be higher on an absolute basis. So let's also keep that in mind. The industry is moving in the right direction.
I mean, I think it's phenomenal. In the last, 5 years, the pricing of global pricing has come down to 9 cents or 7 cents per watt. Five years ago, it was in the 20s,
When I started in the industry, a PV panel per watt was $4 a watt.
Right.
Now we're talking a fraction of that, which is incredible.
Yep. Any other questions? Back there.
Hi, thank you so much for talking for us. I was wondering, you talked about how there would have to be some kind of policy incentive from the government in order to bring back solar panel manufacturing back to the U.S. What kind of policy would you really be looking for from the government for this to happen?
So just to reflect your question, can you talk about what incentives made us do that and what was helpful and supportive?
Yes, and what would be even more helpful in the future?
Okay, good question. It comes back down to that the US government has understood, and we have educated over many, many years, that manufacturing here is simply more expensive than in Indonesia, Thailand, Malaysia, you name it. And with the Inflation Reduction Act, there was actually policy put in place which is helping us to bridge that cost gap per manufacturing step for the module assembly, the cell manufacturing, wafer manufacturing. Not always exactly what the true cost gap is, but pretty close. So this incentive, which is a tax incentive for us, has helped us tremendously to make the product more or less cost competitive from an import versus produced here. Now, whenever you decide not to produce according to these supports and laws, longevity is key. We have seen it in many other countries where there's an incentive for a year or two, but your factory takes us 3 years, or the investment takes us 3 years to get the money back. So there was a mismatch between an incentive and the actual commercial calculation of it. So longevity of an incentive rule is key. Gladly, the IRA is valid up to 2032, so it helps us to make long-term decisions and significant capital decisions. If this would not be given, we would just sit on the sideline and watch and see what's happening next. Does it make sense?
But to the second part of your question, what else could be implemented to be helpful? I think this goes down to the comment we were saying is like if there was incentive support throughout the whole supply chain, that would be very valuable. It's not just the module, cell, ingot, and wafer, but also the subcomponents. It's good. There's tariffs on the equipment that's coming in, the automation equipment. So just looking holistically, that would be great. But once again, ideally, that those incentives I know are going to be hard to draft at this point. But it's avoiding the tariffs in the first place would be the other side.
Yeah, just sort of big picture for a minute. I mean, U.S. trade policy favors the underdog, as I mentioned before. And the users of the product, like if you take solar panels, right, the users and the purchasers of these solar panels, developers like Strata and so on, suffer because the costs go up because people within the industry can bring a case which causes, against China, for example, which causes the product to be manufactured in another country, which is more expensive, and so, prices go up. And the point is, to me, the big picture is tariffs are in the news a lot, but it's not so far actually been anything presidential that's caused most of the trouble. It's problems from within the industry. And the reason is because the trade laws are obsolete and they're not really appropriate for a country that's trying to manufacture things. Almost every company that manufactures anything in the US is right now very concerned about the tariff on the materials that are coming into the US to be able to manufacture. In other words, the tariff makes manufacturing in the US not feasible, right? There's so many inconsistencies. So to answer your question, I mean, I think that ideally over these next few years, there will be a serious look at how to revamp all of the tariff trade policies and use them appropriately, use them sensibly, and make manufacturing in the US make trade policy support manufacturing, not destroy it, if you know what I mean, which is essentially what happens. And it's true whether you're making cars or motorbikes or airplanes or whatever. If you're importing the materials and you have to pay a tariff on it, you can't compete anymore, right? So anyway, it's all complicated. All I know is it doesn't work very well. And so ideally someone would spend a lot of energy fixing it all.
Yeah.
Since we're fixing everything else while we're at it right now.
Just to give you an example, yes, we want manufacturing in the US. Let's assume you're importing $100 million worth of machines and equipment. To do so, you're paying 25% import duty on those machines, and there's no exemption for it. So you're paying 25 million over 100 million just to do the right thing, what people want us to do.
Do it somewhere.
Right. So I think that's the on the one side, there's a carrot on the IRA, and controversial, you're being penalized for actually doing what we're being asked to do.
Right.
Well, and by the way, nobody knows where that money goes. It just disappears.
We're at our time, so thank you, Andy, Nigel, and Thomas, for your leadership in this industry over the last 15, 20 years, and all the progress that was made was because of that leadership. So thank you very much for being here.
Great pleasure. Thank you.
Thank you.
Okay.